All right, we're on 1.4, Compositions of Mixture in AP Chemistry, Unit 1. Let's get started. So, we start off with states of matter. There's 3, solid, liquid, gas. Well, excluding plasma. So, what exactly is a solid? A solid is a form of matter that has its own definite shape and volume. So think about wood, iron, paper, sugar. They're all examples of solids. The particles of a solid are tightly packed together, and when they're heated, it expands, but only slightly. Now, because of this shape that being definite, the solid might not conform to the shape of the container what it just placed in. So if you place a rock in a container, the rock will not take the shape of the container. Obviously, it makes sense, right? Now, moving forward, liquid. Liquid is a form of matter that flows, has constant volume, and takes the shapes of the container. Some examples would be your blood, water, orange juice, mercury. The particles in the liquid are not as rigidly packed together as a solid, but they're closely packed together. Now, the volume of liquid is constant, regardless of size or shape of the container which the liquid is held in. However, like solids, liquids tend to expand when they are heated. That is a key pointer here that is similar between solids and liquids here. Okay. All right. Moving on to gas. So, a gas is a form of matter that only flows to conform to the shape of the container and fills the entire volume of the container. So, what that means is if you flow gas in a container and close the container lid, the gas will expand and fill the container, right? Makes sense. Because gas particles are moving fast and they're moving unlike ice and water. Alright, so compared to solids and liquids, the particles of gases are far apart. They move so fast and take the shape of the container that they are really far apart, which makes these spaces easily compressible, so gives gases a property of being compressed. Alright, so here on the picture to the left, we see ice, water, and steam. Well, we can clearly identify this is solid, this is a liquid, and this is a gas. So if you see, in ice, the ice particles or molecules are tightly packed together in this shape, hexagon. And they don't move unless you heat it. They'll expand a little bit, but they'll still stay close to the same. Unless you add so much heat that the ice turns into water, right? Now, in liquids, they're still close together, but they're able to move freely, right? Like if you have water, you pour it from glass to glass, you make it bigger, you take the shape of the container, right? So that makes sense. Now, here, the big one, gas. These particles, if you see this, they're moving. And they're moving so fast that they create this heat. Now, since they're moving so fast, here you see they're compact. Here they're loose, and here there's only 2, meaning they're moving so fast and they're so far apart that they take the shape of the container. Alright? Now, let's go ahead and move on. Classifying matter according to its composition. So, here. So, matter is classified in 2 broad categories: pure substances and mixtures. So, a pure substance is a form of matter that contains, that has constant composition. So what that means is that it's same everywhere. So if I take part of it, it's going to be the same as if I take a different part of it. And the properties that are constant together throughout the sample. It's meaning that there's only one set of properties, such as the melting point, the boiling point, and it's the same throughout the matter. So, moving forward, a Common examples of these are elements and compounds. So, what exactly is an element? Okay, so a substance that cannot be broken down into chemically simpler compounds is an element. So think about copper, nickel, boron, silicon, anything. Anything from the periodic table is an element, right? It's a periodic table of elements. Now, going forward, compounds. A substance that can be called a compound can be broken down into chemically simpler components is called a compound. So, for example, water is a compound composed of elements, hydrogen and oxygen. Okay, so what do you think is more common, or there's more of, elements or compounds? Now, if you said compounds, you are correct. There's millions of compounds versus elements. The elements that are in the periodic table are the only discovered elements that we have found to date. So think about that, and then there's tens of millions of compounds. All right, moving forward. And yeah, material composed of two or more substances is a mixture. Makes sense. So here is a pretty much a hierarchy that shows every, from general to the more complex. So if you look over here, we have matter. Matter is the most simplest. Anything is a matter, right? Anything that takes up space is matter. So here we go from matter to pure substances, we just talked about them, to mixtures. Now, we also talk about elements and compounds. We'll talk about homogeneous and heterogeneous in the next slide. But just be familiar with the slide and just take a screenshot of it, as it's a really good hint for your AP exam, which you can keep notes of. All right, now moving forward. Mixtures. So here, this ordinary table salt right here, which is called sodium chloride, NaCl, it's considered a substance because it has uniform and definite composition. All samples of sodium chloride are chemically identical. Water is also a pure substance. Salt easily dissolves in water, but salt water cannot be classified as substance because its composition can vary. You may dissolve a small amount of salt or a large amount into a given amount of water. A mixture is a physical blend of these two compounds, right? It's composed of two or more substances. So, salt and water, two substances. So, this will help us here. What exactly is homogeneous mixture? Homogeneous mixture is a mixture in which the composition is uniform. This is the key word, uniform throughout the mixture. So, let's say I have this compound. It's not really a compound, okay. If I cut it in half here, or if I just cut it here, this part here and this big part here are the same. Same in both physical properties and chemical properties, boiling point and all that. Because it's homogeneous, right? Okay, a common mistake that people do. It's often confused with pure substances, since pure substances we talked about here, they are similar, but they are not the same. They both are uniform, but pure substances have the same composition throughout. So, think about it this way. The only difference is that a composition of a substance is always the same. So, example, we have here tea or coffee, whatever this is. I take this part or this part, they're the same, right? In physical appearance and chemical properties. If I were to boil this part, forget about the amount. Yeah, amount and all that stuff will be different. But this part and this part are the same. So that's what homogeneous is. Now, moving forward. Heterogeneous is a mixture in which the composition is not uniform throughout the mixture. So, Think about anything you eat, like trail mix, your snacks, whatever you want. Here we have trail mix as an example. We have different kinds of things in here. Like, look, we have M&Ms, we have raisins, we have peanuts, we have almonds, we have cashews. So these are a bunch of substances mixed together, but you can clearly see they're not uniform compared to this coffee or tea here. This is perfectly uniform. This is not, right? So this is a heterogeneous mixture. Another example would be vegetable soup. Any given spoonful of that soup will contain varying amounts of different vegetables and even compounds of the soup, right? Let's go ahead and do some practice. So, the question asks, identify each substance as a compound, an element, a heterogeneous mixture, or a homogeneous mixture solution. So, it says filtered tea. Take a second and figure out what that is. Alright, so if you take a minute to do all these, that's cool. Now, what exactly is filtered tea? If you guess homogeneous, you are correct. Because of its composition of the solution, it is uniform throughout, right? We talked about it here. It's tea. It's uniform throughout, right? So it's a homogeneous mixture. Now, freshly squeezed orange juice. What do you think that is? Now, orange juice contains particles of solid pulp, right? As well as a liquid. And it's not chemically pure. So because of this composition, it is not uniform throughout, which is why it is heterogeneous. Now, next question. A compact disc. So a compact disc is a solid material that contains more than one element, with regions of different composition visible along its edge, right? So, it's not chemically pure. We know that. So the regions, because of these regions, different compositions, we know that it's a heterogeneous mixture. Aluminum oxide, which is a white powder that contains a 2-to-3 ratio of aluminum and oxygen atoms. So, to me, this looks like a pure compound because it tells you that it contains these atoms, and a compound we talked about is a pure substance. Right? Look over here. Pure substance, it has compounds. So, you can go ahead and say this is a pure compound. Alright, next one. Obviously, periodic table, it's an element. Right? So, that's all for today.